I don't do anything with those, just so you know.
But it would allow him to retake a pop quiz.
I'm surprised.
No.
Okay, as an excuse, right?
No. If it's a unit.
If my mom dies, you're gonna tell me I can't retake a pop quiz?
I make exceptions under like rare situations, but if it's only for like university sanctioned activities.
My grandma passed away like 6 times last semester. It's crazy. 9 lives, bro.
She's a fighter, huh?
Yeah.
If she's a cat, she has 3 more.
I kept telling everybody she just doesn't have DNR on her ID card, so every time she clocks out, they just keep bringing her back.
Okay, I'm sure that's disrespectful at some level. Okay, so graphs. Do you guys are graphs something like, yeah, they're cool, I like them, they're visual, or it's like they're the bane of my existence? Like, where are we on that spectrum? Like, love them, interesting, really, if I have to hear about them again, this, okay, mixture, okay. Some of you aren't voting, okay, you're American. Okay, so let's jump into this. I created some exercises. I thought this would be a good way to tackle this information. And so this might be news to some of you, but what I want you to do is work in groups to pull these activities together. Now, I haven't told you the prerequisites. I haven't told you the ordering here. I want you to use your innate genius to come up with an ordering that makes sense here and put these in a topological order, but they need to have some structure here, okay? So let's do that, and let's bring them together and discuss what we have. I guess, you know what, how many white? We've got a couple whiteboards, so when you're done and you want to draw it on the whiteboard, you can just abbreviate, then do that. I'm talking small groups, and so not every group gets to do it on the whiteboard, but those that want to, let's do it on the whiteboards for 5 minutes. Corey?
Does the list of activities include activity and select activity?
Yeah, so this is doing the activity. So this is being recorded, so let me be careful with my words. There are stereotypes of computer science students, and so I thought this could be helpful for soft skills to talk about various steps to going about a date. Okay?
Yay, we're learning.
Now, I told my students a couple years ago I had a hot date, and they said, Dr. Kerr, we thought you were married. I said, I am, and I'm trying to stay that way. So this doesn't apply to just single people. So anyway, I thought some of this would be good information to review. Okay? Your parents actually called and asked me to insert this. Some of you are laughing. That was for you.
Parents have no idea what's going on with my school.
And they legally don't have, I cannot legally talk to your parents without your permission.
Well, I hope
So
so.
that's the way it works, by the way.
Oh, yeah.
So I've had a parent come in with the student, and I was like, can I talk with your parent who is in the room? And the student said yes. Surprise. Anyway, so let's go through these. Some of these, like, you need to select an activity before you can do the activity. That's a prerequisite that's kind of in there. Okay, so small groups, let's divide them up, and then we're going to talk about it. Luke.
What's pickup day?
Pick up a date? Like, go to their residence and open the door?
Oh, pick up the day.
Yeah, okay, sorry.
Cool.
This isn't plums, or, sorry. Okay, who wants me to be in their group?
I'll take you. My partner's not
Okay,
for today.
group up front. Okay.
Okay.
So do you want to just take one and define an ordering, or are you going to, are you taking multi, or you want to define all the prerequisites?
I was gonna look through the list and kind of scroll it.
Sure.
So you have to just select activities before you do the activity. In my
Activity is probably
you do dinner is the
Night
activity.
also.
Well, that was great.
Is dinner before the activity or after? Is that just like the I prefer to do the dinner before the activity. So for the example, the activity is like going to the movies. So do you normally go to the movies vendor? Actually, I'm just the wrong person for that one. Anyways, so I would do select the activity first, and then dress and groom,
Said anything about that.
We gotta do his phone.
and then buy flowers. Ooh, scratch all that. Select activity, make the dinner reservations, then get dressed, then go get the flowers, then pick up the date, then go to activity, then go to the dinner.
I like it.
That is all.
Okay.
Whee!
It got quiet all of a sudden. Did everyone finish at the same time? Okay, we have one on the whiteboard here. Anybody else want to put theirs on the whiteboard?
Nah.
Do it. Okay, we have selected activity. And I'm assuming there's some arrows here. I assume top to bottom is the arrows.
What else? Oh, yeah, it's directed, sure.
It's directed, right? So you have to select the activity before you make dinner reservations, okay? And you need to dress and groom.
At the same time as making dinner as well. Speakerphone.
It could.
Speaker.
Okay. Buy flowers. You need to be able to go out in public before getting the flowers.
Well, what else you got for flowers for them?
And for timing. And so flowers are just before picking up a date. And then dinner or activity. There's probably some ordering here, but it's not clear from the context. Okay, who is dinner then activity and who's activity then dinner? Dinner then activity.
Activity and dinner.
Activity then dinner. Okay. Say, you know, this isn't going to define your final grade, but okay. Luke,
Yeah.
we have select an activity, dinner reservations, buy flowers, dress and groom, pick up activity dinner.
I'll say grab, boss.
Obviously, yeah, I
I
forgot I was
asked
supposed
for
to
it.
do that until I looked over and seen that one.
I asked for an ordering.
Was
So
that
that's orders apply.
No,
It is.
there's multiple paths here.
with yours, you might never, ever, you might not, you might go to McDonald's, you don't know where you're going to dinner.
Tom slice to do speakerphone. Happens at the same time as dressing and grooming. You said I could draw that way.
Okay, I think it's very instructive to draw as a diagram. Okay. And it illustrates we have some different things here. But what we're talking about is we are covering topological orders. And so whether you knew it or not, I think you were processing kind of a topological order algorithm in your head while going through that. Now, let me provide a diagram of the field of study requirements for those of you who aren't incoming freshmen. That's none of you. This is Area F, if you're familiar with that from like DegreeWorks. This is the new Area F name. So these are Area F courses. So let's produce a topological order from these. Okay, and let's see. Let's do group effort here. I'll type. Let's see. Let's go a little smaller. I got my... There we go. So how would we do a topological order from this digraph? And you've all taken all... Well, actually, you don't have to have taken all of these. I won't ask. I was going to say, is anybody delayed one or two of these classes? Okay, some of you are like, yeah, I haven't taken that yet. Okay. Okay, so how do we make a topological order from this digraph? Coco.
You start with a node that has no parent.
Okay.
And you put that at the top of your topological order.
So let's use graph terms. What do you mean by no parent? A vertex that has... What's the terminology? Lifeline. She needs a lifeline. She's floundering. Jack.
In degree vertices.
What?
Approved?
Not, it's not necessarily a tree.
No in degree?
In degree of 0. No in degrees, or in degree of 0. Okay, so we're looking for vertices that have an in degree of 0, meaning in this context, they're not a prerequisite for anything. So this is, your friend is like, hey, you're in computer science, you're amazing. It's like, yes, thank you. I want to do that too. You're like, okay, where to start? So what do you take first? Computer Science 1, okay. Take that first. Then what? We're doing this is, oh man, I'm working 2 jobs, but I'm going to get this degree even if it takes me 8 years. So I'm going to do 1 class a semester.
Okay.
What class should I take first? Computer Science 1, great. What should I take the next semester?
Pre-calculus.
Okay, pre-calculus. Next semester.
You have a couple options.
1302 was what I heard. What else? What in the 4th semester? Next.
Computer organization.
Next.
Cyber 2159.
That's our only choice.
And Cyber 2160.
And I'm gonna, let's see, computer organization, it's a prerequisite for something, right? And so,
Is it computer architecture? I think it's computer architecture.
oh,
Oh, wow.
yeah, for the software systems degree, and it's not a prerequisite for anything. Okay, so you could have waited to take computer organization until now, or you could have waited to take intro to info security until now at this level. Those are, you know who you are, or you should know. Okay. So what are 3 algorithms to come up with topological order? How can we come up with a topological order? We've been doing it, but let's talk about them.
Breadth first search count as one.
Tell me more.
We could just pick, and we go by the individual layers. So we could start at the very top. We did 1301 and 1113. Then we move to our next layer. We could do, I think we did slightly different ordering.
Actually, we would start from here and proceed.
And go from that one to 2159 and then 1302, and then from there it would be 2160. And I'm assuming you could still. Oh, discrete map counts as a. Discrete map counting is a. What do you call it?
Oh, the dashed lines are concurrent prerequisites. Sorry, I'm gonna guess some of you are wondering that. Meaning you can take them at the same time as, or before. Okay, so that's what I thought. I'd leave that in. But graphs usually it's either like it's a there's an edge or there's not is how we usually look at it. But in the real world,
Especially every time we look at this graph.
okay, you've seen it before, hopefully. Okay, so breadth first search. How would we tackle that?
We would have to have a way to get back to the pre-calculus node. But
We would. We would have to be able to do that. Okay. Need a way to start at each vertex with an in-degree of 0. So if we could consider each of those in layer 0, then we could use a breadth first search. That would work if we made a slight modification to it, almost like a layer -1, and then had that reach all the layer 0s.
If those are concurrent prerequisites, could you not go backwards?
No, you have to.
You could take them at the same time?
Yeah, okay, so this analogy breaks down a little bit because some of you are taking more than one class per semester, and we're talking about an ordering here, and semesters kind of group them together. I did know a student that was taking 2 classes per semester, and he graduated like a year ago, so I was impressed, like stuck with it for a while and finished out. Okay, so we could do breadth first search. Start each and we need some way to include it so that we are getting them all of the vertices. But would that work? Would it? What if we added? Let's see. Is there a situation I can just pull from here? We don't. I'm trying to look for something that's a prerequisite at a higher level. Let me see if this is, here's my monster graph. Okay, so I was playing around with this, if you can't tell. I'm updating these. Is there anywhere where we have an in-degree of 0 and it's not an introductory course? $21.15. Okay. Unfortunately, we are retiring that course, but in terms of example, but here we go. So the problem is with breadth first search, if we were doing all of the vertices that had an in-degree of 0, then this would be included as well, and then we would explore this one in the second layer, but it would need to wait until after Computer Science 1. So this would be in layer 0, this would be in layer 1, and these two would be explored at the same layer. And so we'd need to do something different there. Okay, so breadth first search won't work. What else? Coco.
I feel like there was an algorithm that we did in data structures, which is similar, but it starts the reverse order. So it starts with vertices that have no out degree of 0, and then it adds the vertices towards the end of the list instead of at the beginning of the list.
For each vertex with an out degree of 0, then what? Out degree of 0. So to be clear here, which of these vertices have an out degree of 0?
Cyber 2160 and computer science 2105.
Okay, and what else? 1302 in this graphic, because I just snipped off a whole bunch of edges to produce this one. Okay, for each vertex with an out degree of 0, so one of these 3, do what? I like it. Put it on the blank of the topological order list.
Put it at the end.
Put it at the end?
Yeah.
Okay. Okay, so let's pick one here.
Wait, I think the wording of that is kind of weird because then it's like continuously put things on the end of the list, but it's you start at the end of the list and then you add vertices in front of the.
So how about instead of end, we do beginning?
And then continuously add at the beginning. I can
Yeah.
do that.
Of the current topological list, and remove that vertex, okay, so that we make progress. So let's just call these out to be efficient with our time. Which one first? Which one do you want to take last? Okay, well,
2160.
who's are we waiting to take 2105 or 2160?
2160.
2160. Okay, so let's put down 2160, okay? Okay, that's at our beginning of our list. Now we would remove that one. Now, which options do we have for vertices that have an out degree of 0? 2159, 1302, and 2105. Okay, which one do we want to put at the beginning of our growing topological order list? And so I feel like that's worded funny. It's a list. Topological order is a list. What do we want to take? What would you take? What would you want to take last?
So 2105 again?
2105? So, no, would you see?
That's what we're working our way up.
So we can take any of these and have a valid topological order.
Just do 2105.
2105, okay.
There's no hanging fruit there.
Then we would remove this one. Now, which ones have an out degree of 0? Remove these two. We've said this one has an out degree of 0, this one has an out degree of 0. Did we add any more?
Math 2125.
2125. Okay, so now what do we want to add to the beginning of our topological order list?
2159.
Cyber 2159. Now we remove it. Do we any more vertices have an out degree of 0? No. So what was left on our list was computer science 2 and intro to discrete.
Intro to discrete.
Okay. Now, did that open up any more? No. So we are forced to add this one at this time. Okay. Did that open up any more?
Yes.
It did. Now all of them have the remaining 2. So what do we want to take? What do we want to add next? Okay. Yeah, and there's only one left, so I'm assuming you're going to choose that one. So it feels a little funny to put it at the beginning of the list when it's an out degree of 0. It's like, wait, we just identified one that's low down on ours. So in Caleb's graph here, Slim Coco's graph here, we have either activity or dinner or make reservations. Oh. Wait. Does that strike anybody as odd? We could choose any of those to be the very last one.
Yes.
It's not deterministic. You go both ways. Both states exist at the same time. T1.
What if it's dinner for tomorrow?
There you go. Yeah.
Yeah, you're already thinking of next date. Is that what it is? Same person or different person? Okay. Sorry, too much information. Okay, so it seems like what you're saying, Slim Coco, is that there's actually more information there, that all T not activities, or so let's T sub 1 activities have to happen before T sub 2. Is that correct?
I'm sorry. One more time. I'm listening.
So I feel like there's some invisible edges there by drawing the I'm not sure. So we've talked in breadth first search about layers. Oh, T is time.
Yep.
Okay. So then what is implied here is that dinner reservations need to happen before buy flowers.
Yes.
Okay.
Yes.
And then that would force everything to observe the time scale that is provided there. Okay. Okay, so then that would not allow us to choose dinner reservations. Here, let's just do this. We're already going to ask for it. Use your imagination that we've deleted these. We could delete these. Okay, we have that one. Sorry if you're watching this recorded.
You don't have to do that.
Do I have to do what?
You don't have to do that.
Well, okay, if we don't, then we can choose any of these three and have a valid topological order based on the graph. And then that would put you showing up at dinner and then making the reservation. I knew this was good to bring up. Look at this. Look at all these life skills you're gaining from this. We needed something to talk about. So I thought
It's implied that those are happening at the same time, at the same.
Yeah, but he's talking about doing it with that algorithm. So by doing it with anywhere that has an n degree of 0, if we don't have that
Yeah,
going here, then
yeah.
that has an n degree of 0.
Talking about an algorithm 0, the second algorithm proposed.
yeah, we're on the second one.
Yeah, sorry.
We
He said
haven't
in degree.
figured the first one out.
Out degree, not in degree.
I was trying to say in degree.
Oh, I got you.
Yeah, the out degree, sorry.
Okay, so
yeah,
if we were
try
going to
it.
choose this, we would do what first? What would we choose?
Activity or dinner.
What's the vote? Activity or dinner? Do you do very last?
Activity.
Dinner. Dinner.
Yep.
I'm hearing more dinner votes. Okay, so 1, 2, 3, 4, 5, 6, 7. Okay, so 7. Okay, so then what could we pick?
Only activity.
Only activity. 6. Only pickup date. 5. Only buy flowers. 4. Now what could we pick?
Dinner reservation.
Either of these, on your speakerphone or getting ready. Okay, so what do we want to do first? Well, I mean, depending where we're getting dinner, it might make a difference. Are we talking black tie or are we talking
Well, I gotta be getting dressed, going on the phone, so you know going.
So dressing room would definitely,
we'd recommend that could maybe I shouldn't. Okay, and then we have to do this one next, and then this one would be first. Okay, that's that algorithm spelled out. Okay. What other algorithms are there?
So couldn't you know what level you're at and know that they have to happen at the same time based on the graph? I don't feel like that would be hard auxiliary functionality to add to the algorithm.
So the
Then you wouldn't have to connect dinner reservations to 5 hours.
right, I mean, because you really could connect dinner reservations before pickup date. You could buy the flowers and then make dinner reservations.
Correct.
It'd be bad form to pick up the date and then make dinner reservations.
Okay.
So,
Unless they cancel. You never know. But yeah, for real, yes, I got you.
okay, so the buy flowers felt a little arbitrary, but the pickup date does feel like I think we'd have agreeance on that one. And so so your question is, can't we just encode the graph to have more information? I mean,
The graph already has the information, right? What level you're at, which is the question I asked you before I drew that graph.
so assuming it's a tree,
Sure.
okay,
Which is a subset of a graph. Tree is a graph.
right. And we're talking about DAGs here, directed acyclical graphs. Okay, so
You have to parameterize your algorithm to the topological order that and say, hey, it has to be a tree of this form, right?
yeah, but that complicates it to provide that restriction.
It also gives you more freedom to not say, okay, we can only execute these tasks sequentially. But it's still an order.
I mean, you could just go through and do all tasks at a time band in that order. But I think the point is you have a graph and you're trying to establish that is usually what you're trying to do. And so that's like if you're given an ordering, can you come up with an ordering? Well, yeah, I can, but you're already most of the way there. Okay, so what other algorithm can we come up with?
Would be virtually the same thing as the second one. So going back to 1, I think it'd be the same thing as 2, where we'll take one that has an degree of 0, put it at the beginning.
For each vertex with an in degree of 0, put it at the
Add it to the list.
put it at the end of the topological or the list and remove that vertex. Okay, so what would that look like here?
You can pick out a computer science 1 or pre-calculus.
What do you guys want? What do you feel like?
Computer science 1.
Okay, we'd do this one. We'd remove this one with its 3 edges. Now what could we choose?
Either pre-calculus or fundamentals, given that working. So,
Either of these, given what people said earlier, I'm going to guess we're going to go with pre-calc. Okay, and then now this one has an in degree of 0, this one has an in degree of 0, this one has an in degree of 0, and that's it. So we could choose any of these 3, would take one off, would put it at the beginning of the list. This is more, I feel like, natural, like what would you take when? I want to take that one, instead of like working from the back forward, which I'm sure some people think that way. Okay. So I called for 3 though, so we came up with 2. These are generally the 2 we come up with, but I felt like this one had promise.
That's what, you just did that.
that's what I was building off of, yeah.
It's directed, so if you started at each node with an in degree of 0, you have to, the whole thing's removing it. And then.
You're saying it's very analogous to a breadth first search to look at the in degrees and tackle it that way. Except breadth first search is establish everything at a layer, and you don't care about prerequisites.
Well, layers, right? Neighbors.
No, but if here,
Computer science 1 is, we has to proceed computer organization. But I guess layers is.
but see this one is layer 2 from this standpoint, but layer 1.
Right, that's what I'm saying. It's depending on the size of the graph, it's, I'm not gonna say ambiguous, but it's.
Well, it has to work. Okay. Well, no. Okay.
Like if you're doing breadth first search on a graph, you look at the neighbors, where you start at this node and you look at that node's neighbors. It's not exactly level, per se. Right? Because you have computer organization, which depends on computer science 1. But computer organization also depends on discrete math, but that doesn't depend on computer science 1, which is why your layers can get ambiguous.
Right. Okay. What if we did a depth first search?
Isn't that the one? Isn't that basically number 2? Because you start at the deepest quote unquote layer, see what doesn't have it. Anything after it, you put that on the list and then you work backwards.
We'd put them in reverse order. Reverse order, we could get it. Notice the ordering is very different here. We still need to be careful about.
It's not strictly breadth first search though. I would argue.
Right. I was thinking we could get away with a depth first search or a breadth first search, but
No, well, I mean, you have 2 nodes in the graph's original state that have an in degree of 0. And that aren't connected in a way that in which you can follow, right? Because it's directed. So you have pre-calculus over here, computer science over here are no way connected.
So you could go down the left side and then even get to computer science too, but there would be a way to get.
Yeah, you could take CS2 fundamentals. You
I mean-
could order CS1, CS2 fundamentals, intro, and then computer work. But you're now disconnected from pre-calculus and intro discrete.
yeah.
So I don't think it's strictly breadth first search.
No, we would need to modify it, and it's not a trivial modification. let's talk about the big theta, big O, big theta.
Do we have a third algorithm?
We don't yet.
Oh, okay.
So, be famous. We can call it the Slim Cocoa method.
That's the Slim Cocoa method.
Given an order, find an ordering.
Hey, that's a declarative programming, isn't it?
Okay, so let's talk big theta, okay? So we could talk big O or big theta. So let's choose one of these algorithms and let's talk about it. That's where really the focus of this course is. So we put this up here so that we can. So how long would this take? What are the steps involved to be able to accomplish this? The description's pretty short. That's nice. So for each vertex sounds like what? N, because remember n equals the size of the vertices. No, that's okay. So n. Okay, so order n. For each vertex, do what?
Check the out degree, so that would be the edges.
So we need to figure out which vertices have an out degree of 0.
So that's
So we need to go through them and check each one to
We-
see if it has any edges going out. So n squared?
in notes. Wouldn't that be in constant time operations?
I would argue for n plus n because each iteration does not check every single nodes. So it's like, hey, look, you check, be like, hey, does this have an out degree of 0? If it does, then add it to the topological order and then delete it. But if not, then you go to the next one on the list. So it may take all n nodes, but it's not likely to check each node every iteration.
But if you're doing an operation for each of the n nodes, worst case here, then you would be multiplying whatever operation you're doing potentially at each node. Since you would have to multiply that, that wouldn't be an addition. Right? So whatever our operation is, it's going to be n times that operation. And so if we look at the first sentence, for each vertex with an out degree of 0, however long it takes to find out if it has an out degree of 0 could potentially happen n times. Which I would argue that's a constant time operation. We can take the length of the list of the nodes that it's connected to if we're looking at a list. So
Coco.
Let's expand it by saying there's a separate list that keeps track of all the out degrees of each vertex.
Say an adjacency list.
that's what I was getting at.
Yeah. Like I heard you and I was thinking at the same time, so it just kind of conflicted. But yeah.
So if we had, does it matter if we use an adjacency list or adjacency matrix here?
So we know. Oh,
I'll tell you what.
I'm gonna embarrass myself.
It's okay.
We know it's quicker to find all of the nodes that it's connected to an adjacency list, right?
Yes.
So if we want to similarly count the number of nodes it's connected to, or it's going out to, right? I would say.
We could store the length of the list with no additional
Right. So
cost.
complexity. So I would say for this operation, this part of the algorithm that we're talking about, I would say adjacency list.
If you use the matrix, would it be n squared?
So
Probably actually.
But if you use the list, it would be not, it wouldn't be.
adjacency matrix,
Right. That's what I'm thinking.
it's going to be n squared.
I'm thinking it'll be closer to n to go each vertex and find the ones that out degree 0 if you're using the adjacency list.
So adjacency list, on the other hand,
N times n constant time operations, so just n.
so we every time we find a vertex that has an let's do this one. Every time we have a vertex with an n degree of z. No, hold on.
No, so we'll do the first sentence, 4 steps, right? So for each vertex with n or out degree.
If we sorry, if we kept a list of vertices that have an in degree of 0, then we could very efficiently figure out what they're adjacent to update those and say, hey, I'm going to reduce your in degree by 1. Does that put you on the candidate list for one to be added to the topological order? And we could very efficiently go through that by adding in a list of vertices with an in degree of 0, and then we just update them as we remove the vertex, only updating the ones that are adjacent to the vertex we're removing.
So we don't have any cyclic dependencies, right?
We can't. It's like you'd have to have. It doesn't make sense in here. You'd have to already be. You'd already have to have gone to dinner before dinner reservations like this.
So if you are in a node's adjacency list, then we know that you have an in degree coming from that node, right? And we know that you will not have an out degree going to that node.
Correct.
That's cyclic dependencies, right?
Well, and when we're doing this is when we're removing it.
Right.
So it was already in degree of 0.
So if you're looking for all of the nodes with either way, let's say you're looking for all nodes with an out degree of 0, for instance, you would look for the node with an empty list, right? You would take the length of the list for each node.
Oh, I'm sorry. I jumped ship to number 3. We're doing in degree.
Okay.
Because it's already set up, because the out degree maps very well with an adjacency list.
Right. So you want to do, so we moved on from that. I thought that the whole discussion we were having about matrix versus list was in regard to number 2.
We started that way.
Because I got super confused when we moved on. So what are we doing before I continue?
We're talking about identifying each of the vertices with an in degree of 0.
For number 3. And then
For number 3. So then we're keeping a list of those. And then we pick one off of there. It doesn't matter which one. And then we'll follow the adjacency list for that one. And for each one of those, we'll say, reduce your in degree, reduce your in degree. And if it goes to 0, then we say add it to the list.
Because if you don't do that, then you're going to have to go through every adjacency list for every node. If the node in question is not there.
So what is its big theta?
With your list.
With an adjacency list, yes.
So you're saying you're starting with a list. We're starting with another list of vertices that have an in degree of 0, right?
No, we're going to start with an adjacency list. What's the big theta to calculate a topological order? So producing the list of vertices with an in degree of 0 is part of calculating the topological order.
So we're counting those steps as well.
Yep, so we know that's n.
You're going to have to go through every adjacency list for every node to search for your first node. Let's say you start with node 0. You're going to have to go through the adjacency list for every node. Because if it's in a node's adjacency list, that means it has an in degree. If it's not in any of the node's adjacency lists, then it doesn't have an in degree. It could have an adjacency list, but those are out degrees, right?
For this specific implementation with the adjacency list, the reverse, because it's a directed graph. So normally when we have adjacency list, it's like this is, say we have 2 nodes U and V, and in order for it to be directed, it says it has an edge from U to V. So in the scenario where we're determining it from the in degree, would you reverse it? So the adjacency list is like, hey, there's a node, there's an edge from V to U, or reverse the words, so I confuse myself.
So we could, in order n plus m time, go through and build one. For each, we need to go through for each vertex and for each edge, And so we could build that reverse adjacency list, and it would take us n plus m time to be able to do that. That's an option. So to do this with an adjacency list, we could just always look at every single one of them to determine the degree, and that would be n squared. But we can, by maintaining a helper list, we can do it in order n plus m time, although that feels a little weird because it's out of order m plus n time, big theta of that, to get a smaller bound, to be able to do it even faster. Now, to motivate this, we can throw in some numbers and see how this is wildly different if we're dealing with a very large project with a lot of dependencies. This is going to make a huge difference just by adding in a helper data structure to accomplish this. Okay? This is what I really wanted you to focus on for today's lecture. Is it with an adjacency matrix, or if we're not keeping track of vertices with a low n degree, it's going to be n squared. But we can make it m plus n by just having an additional data structure to keep track of things to store them there.
So we do have an additional list.
Yeah.
We need to keep track of one. Otherwise, we're going to end up redoing that work every iteration.
Oh, okay. That was not here.
Oh, I'm sorry. Okay, we need to end. Questions?
Would the big O for the one that we did beforehand be the exact same as long as we also have a list of vertices with a half degree of 0?
Well, like I said, we could reverse it
Okay.
in this amount of time.
Okay.
So then we haven't changed the order.
So for my notes, can I copy it and just change the word n degree to half degree? Love that.
Okay?